All right, what we're looking at doing is adding functions. So if f of x and g of x are functions with intersecting domains, that means they actually have domains that can go into both. You can either add the functions, which it can also be written as f plus g of x. You can subtract the functions, which can be written as f minus g of x. You can multiply the functions, which is f of g of x. And you can divide the functions, which is f divided by g of x. So now what we're going to do is we're actually going to take, and the example here is that we're going to look at these functions and add, subtract, multiply, divide, and see what we get. Note that the new functions has all the numbers that belong to both the domain of f and the domain of g. So it's the intersecting domains. And the zeros of the denominator are always excluded from the quotient. So here we go. This is our example. I'm going to highlight it so that you can see that we're looking at f of x equals x squared and g of x equals the square root of x plus 1. And I'm going to find the domains. So what I did is I said anything can go in here because it's a quadratic. So that's negative infinity to positive infinity. In here I can't have any negatives, so I determine what's going to make this 0 or positive, and that happens to be negative 1. So the domain of g is negative 1 to infinity. Now all they want us to do is add them, so I just take it and add them. And now I have to get the most restricted domain, which happens to be negative 1 to infinity. Now all I'm going to do is subtract them. Take f of x minus g of x. And again, the restricted domain is what we're going to use. Now if I'm going to multiply them, it's just taking x squared times the square root of x plus 1. Now I have the most restricted domain. Now this is division. We're just going to take f of x divided by g of x. Now we don't have to simplify it because I'm not interested in that right now. But my domain is going to be a little bit more restricted because if I included the negative 1 in here, I would get 0 in the denominator, and that's bad. So the domain is going to be from negative 1 to infinity. This one's a little different. We're going to take square root of x plus 1 times the square root of x plus 1, g times g, and anytime you multiply two square roots together, you get the same thing. Now when I look here, it would tell me, oh, I got to have all reals. But no, I didn't have all reals to begin with. All I had was negative 1 to infinity. Now in part B here, we're going to look at compositions. And basically the x goes into the g, and then the g goes into the f of x. So whenever you see compositions, this is one way to write it, f circle g of x, which is the same thing as f of g of x. Now the domain of this is all the x values that can go into the g of x, and all the range that comes out goes into the domain of f. So here's my first example. I'm going to take this and I'm going to find what f of g of x is and what g of x is, and we want to know verify if these are the same function. And we don't have to do anything with the domain, but I'm just going to get used to this. The domain here is all reals. The domain for the g of x is 0 to infinity. So that gives me an idea of what the domains are. Now what I'm going to do is I'm going to take and I'm going to actually do f circle g of x, which is the same thing as f of g of x. And I know that my g is the square root of x. And then I'm going to take whatever my f function is and then put this input here. Alright? Now, I'm only allowed to have the most restricted. So the domain of f of g of x is going to be 0 to infinity. Now I got to do the same thing with g of f. And see if we end up with the same function. So I have e to the x, and then whatever my g function is, and I put this in my input. Now when you look here, is this the same as that function? No. In this function, I'm allowed all reals. Okay? Now when you think about it, I have all reals. Can I take the square root? Now, is e to the x ever going to be negative? No, it's never going to be negative. It's always a positive number. E to the x looks like this. It's never going to be 0. It's never going to be negative. So I can take the square root of everything that comes in. So the domain of g of f is going to be, all reals. Now what I want you to note is that since these are not the same, this doing compositions is not commutative. Commutative means that if I have 2x plus 3, that's the same thing as 3 plus 2x. Addition is commutative, multiplication is commutative, but not compositions of functions. All right, let's look at example 3. We have the domain of my function. It's quadratic. I can have my domain be all reals. I look at the domain of g. In this one, I cannot have negatives, so there's my domain. Now I'm going to look at this and I'm going to say, okay, I now have to find the domains of each and then support it graphically. All right, so I found those. Now I want to find g of f of x. All right, so the domain of f is going to be all reals. The domain of g is going to be 0 to infinity. And now I need to find g of f of x. Well, f of x is x squared minus 1, and g is going to be the square root of x minus 1. Can't simplify it anymore. Now what's the domain of g circle f? Got all the reals, but I can't use all the reals. I can't do anything that's going to make this negative. So I'm going to find out x squared minus 1 equals 0, x squared equals 1, x equals plus or minus 1. What's going to make this negative? Well, let's find out. If I put in here a negative 2, and I'm going to get negative 2 squared is 4, minus 1 is 3, so this is positive. If I put 0, I'm going to get a negative. And if I put 2 in here, I'm going to get a positive. I only want positives. So my domain is going to go from negative infinity to negative 1, from negative 1 to 1. Nope, I don't want that one. And from 1 to infinity, because that's the negatives. I only want the positives. Now we're going to do the same thing with f circle g. So that's f of g of x, which means I'm going to take my g function and then I'm going to put it into my f function. And when I do, I get x minus 1. Now I look at this and I should say, oh, well, it should be all reals, but I didn't get all reals. What I got in here was this original input. So my domain of f circle g is going to be 0 to infinity. All right, let's look at decomposing functions. Now there is no right answer, but what I'm going to do is I'm going to look to see what value of g of x did I put into f of x to get this new function. So I'm going to look at this. This is what I'm looking at. Well, I'm going to sit here and I'm going to guess that g of x is x plus 1. And then I'm going to say that my f of x is whatever this is squared minus 3 times whatever this is plus 4. Well, let's just call it x for now. And I want to see if I get this. Well, let's test this out. If this is true, f of g of x, then what I should get is x plus 1, and then I plug it into here.
On your breath, please come to the high school office. On your breath, please come to the high school office.
And I'm going to put plus 1, x plus 1. And that's exactly what I've got. So this is now my composition. Let's do the same thing here. I'm just going to pick this part here as my g of x. That's what I'm putting into it. I'm going to pick f of x as the square root of x. Now if I am looking to see if this works, I'm going to take my f of x, or my g of x, put it in here, and then f says I take this and put my input in. So those looks like pretty good guesses. Alright, on the next one, we are looking at modeling this function. There's a medical procedure, it's an angioplasty, and it basically takes a balloon, inflates it into the vein, and it makes a spherical shape.